Welcome back to an introduction to basic concepts of maintenance and reliability. In this lecture, we're going to discuss two very important concepts related to the execution of preventive and predictive maintenance. It is the yield and effectiveness of preventive and predictive maintenance. A central question to the execution of preventive and predictive maintenance is whether or not we are actually preventing equipment failures. Because it is not smart to just assume that your preventive and predictive maintenance is working fine and just continue doing it. This is where the concept of yield and effectiveness come in. Let us see how both of these concepts are defined. Yield in this context is defined as the quantity of corrective maintenance work that has been identified from preventive and predictive maintenance. So if the technician or an operator goes on a machine for preventive or predictive maintenance and identifies corrective maintenance work, then it means our preventive and predictive maintenance has yielded a fruitful result. The fruitful result is we caught an issue before the issue could have caught us. As a result, we generate a work order to fix it before it results in a failure. For example, vibration monitoring activity on a pump revealed that its bearing needs to be replaced, otherwise it has risk of failure. So a work order is generated for bearing replacement, which let's say is a 3-hour job. Now there is going to be many such work orders generated for corrective maintenance work identified from preventive and predictive maintenance carried out in a plant every single month. The yield is expressed as how many hours of corrective maintenance work was identified from how many hours of preventive and predictive maintenance work. So let's say that the cumulative hours of all the preventive and predictive maintenance work orders in a month were 1,000 hours in a plant. From those 1,000 hours of work, a total of 200 hours of corrective maintenance work was generated, like the example we discussed. This gives us a yield of 0.2 hours of corrective maintenance work generated per hour of preventive and predictive maintenance work. Now the next question is it a good yield or a bad yield? The answer is not straightforward. Whether a yield is good or bad depends on the state of reliability of a plant's machinery. Given this idea, a reference value that can serve as a starting point is a yield of 0.8 hours of corrective work generated per hour of preventive and predictive maintenance work. So if your plant's machinery has poor reliability, that is, it experiences frequent failures, and your predictive maintenance and preventive maintenance yield is less than 0.8 hours per hour, you need to review your PM and PdM program because it should certainly be identifying more corrective work. If your yield is 0.8 hours per hour, you may still review your PM and PdM program and also look into redesign or equipment modification options that may be causing failures while remaining hidden from PM and PdM checks. However, if your yield is many hours per hour, your plant may be going through infant mortality, that is, a high failure rate at the beginning of equipment commissioning. Nonetheless, it would be advisable to review PM and PdM programs while also checking for redesign opportunities. Now, on the other hand, if your plant's machinery is highly reliable, that is, it experiences failures rarely, and you have low yield up to 0.8 hours per hour, that is fine. It tells you that your preventive and predictive maintenance is not identifying much corrective work because there isn't much corrective work happening anyway. You're not missing something. However, it can be that you get many hours per hour of yield with equipment having high reliability. It would indicate that your preventive and predictive maintenance program is working just fine, but your equipment may need design modifications to not need so much corrective maintenance. So this is how the concept of yield helps maintenance departments understand the quality of their PM and PdM maintenance. Once the concept of yield is clearly understood, the concept of effectiveness can be explained. So let's talk about the example of ball bearing replacement work order being generated from vibration analysis. We yielded some corrective work from it, right? However, let's say that when the technician went on to execute the corrective maintenance, he found that the ball bearing is fine. Root cause analysis revealed slight imbalance in pump's impeller. Such things happen. This is where the concept of effectiveness of preventive and predictive maintenance comes in. Effectiveness is expressed as the ratio of corrective maintenance work orders actually necessary to the corrective maintenance work orders generated by preventive and predictive maintenance. So effectiveness measures whether or not the corrective maintenance work identified from PM and PdM is spot on. A rightly identified work is considered effective. This metric can play an important role in identifying issues in your predictive maintenance technologies. So if a total of 25 work orders of corrective maintenance were generated from PM and PdM, but only 15 of them were spot on, you'll get 60% effectiveness. And as you might have already guessed, the closer your effectiveness is to 100%, the better. So in this way, maintenance departments can use the concepts and metrics of yield and effectiveness to monitor the quality of their preventive and predictive maintenance execution. Let's conclude our discussion here. See you in the next lecture.